Even degree and odds are opposite. You guys can move the little math dance moves in the backboard or on the back wall. I always say backboard. But long story short, evens, leading coefficient positive, we're both going up, right? Both meaning to the left, to the right. But yesterday we learned that to the left and to the right actually has a mathematical notation, right? As to the right, to the right. Sorry, to the right, to the left. So, even degrees, leading coefficient is positive. We're increasing, which also has a mathematical notation to the left and to the right. What if my leading coefficient is negative of an even degree polynomial? What changes? It's a vertical flip. It's a reflection across the x-axis, right? So therefore, I have to the left and to the right decreasing. True? True. Okay. True. But what does that not tell me? This is even, and the leading coefficient is positive. So I know it's going to be doing this. Don't all four of these have to the left, to the right? As x goes to negative infinity, as x goes to positive infinity, f of x is going to positive infinity, right? But what's different with each of these?
There's more squiggly.
Yeah. Yeah. Let's find patterns. Turning points. Ooh, people are talking about vocab. That's actually still, don't worry, I got you. Funny, forget that for a second. Yeah, we're writing it right now. I skipped a page that won't have a look at Maybe tomorrow. Oh, it's so sad. I thought today was Friday for a whole second.
Last week I thought that Thursday was
If it was Friday, it'd be a bummer, because that means we would have already done the jeans day and no one would have paid any money for Mave. And then we would have already done broche bread and no one would have bought any broche bread.
Ooh, can I get
For
extra
Mave.
credit if I wear jeans tomorrow for Mave?
I'll give you a high five.
Yay.
Wait, you should do something fun, no?
Wait, why'd you say you'd give her a high five and you gave her a fist bump?
You should.
Don't
do Mr.
Where is the high five? No, it comes faster to my mouth, but a fist bump comes faster to my hand.
Cause you're like, let me give you a high five.
Yeah, cause I don't
That's what
think
Emily
you're
does
getting
to
high
me. It's very
fives.
infuriating.
Right?
We should
Yeah,
do
I
rock,
know.
paper, scissors battle for
No,
extra credit.
Oh
yeah, we should do that.
Do what?
Rock, paper, scissors battle for
And
extra credit.
and she was like,
You're already getting extra credit. It's free coffee. But no, jeans day is a good idea. I should post a comment on like Google Classroom.
I'm great.
And I'll make something. Maybe donut holes?
That's not what
I would buy I have to get
That's not what ASMR is.
But we have broche bread.
for rock, paper,
Not
scissors
ASMR.
for extra credit? Just one.
Wait, that's your mom?
Broche bread's for sale. I can't do that.
Is that your mom?
Yeah. So I'm trying to get someone wears jeans, trying to reward them.
I make it.
How about,
But I want people to buy broche bread, so I can't take away their appetite.
well, just bring it for us, cause
Yeah, just your honest pre-calc class.
we're the
I
only
want you to buy
one of
broche
a
bread.
kind.
But I don't
What
want
about the swatches? Whatever happened to the swatches?
No, I don't want broche bread.
Broche bread is too expensive and it's too messy.
It is nice.
Donuts
You have to have extra
Donut holes
quarters.
are, yeah, they have to have quarters.
Who carries?
Ooh,
We'll see. I'll figure out something.
if
Oh, I did get pumpkin chocolate chip cookie mix.
Please.
I love pumpkin.
See, what if the sophomore student
I remember
council
my
does
birthday
something for
was
Mave? What if
I
we get
love
extra credit?
pumpkin.
I hate pumpkin.
I hate
Give me the extra credit.
I like
I'm pretty sure your grade in
pumpkin
here
season.
is pretty solid.
I need extra credit.
I'm thinking about everybody.
Misty, I would love some extra credit.
See?
Good thing I gave you an opportunity. Yay!
But I
Alright,
have
so
coffee. I only have Armenian coffee.
So stop asking dumb.
who's discriminating against Armenian versus other coffee?
My
Cuban
grandma
coffee,
made it, so we
Dominican
let me
coffee,
give it away.
American coffee.
Oh.
You're Lily? You could bring coffee to the potluck club though. What?
When is the potluck club meeting?
Our first planning Friday is next Friday.
I never got it.
So the first Friday of every month we plan a potluck, and then the next Friday, the second Friday of every month is we have the potluck.
Oh, that's
So
such
you
a
only
good
have
idea.
one potluck
Potluck a month? Yeah,
Yeah.
because it's a lot of work to do.
I don't appreciate that. I want free food more.
You didn't sign up
I
for
want
it.
free food more.
Parents for teachers only do a potluck every other month because it's so hard. Now theirs is a much bigger deal, but it's hard to do potluck.
Why did I think that was reunion?
Yeah, but you just bring pizza.
Especially if you guys are the ones that are like, I'll contribute chips, but I want like an amazing meal.
I was gonna bring pop.
Hey,
I
let
was gonna bring
This.
napkins
See, it takes work for other people.
from other people.
You guys
Exactly.
are not dedicated.
I am very
We're bringing
dedicated
things.
to Fortnite.
Yeah, we're showing that. That should be enough.
So now that we've recorded how lazy you all are. So, what does N stand for?
Oh, I know.
A polynomial, whose end? What's end?
The exponent.
Yes, with the highest exponent, right, Alex?
Yes.
So, if, focus on the math. You guys can't focus, we can't talk about other fun things. So, n is degree, which this one's degree is 8. We already talked about that, right? N is 8. This is an 8th degree polynomial, or 8th order polynomial, if you want to talk about it that way. 8th degree is better. What does this say about how many possible zeros that guy could have?
It can have 8.
Yeah, it can have up to whatever degree I have. It can have, any quadratic can have up to 2 at most up to 2. Any 8th degree can have up to 8. Hold on, how could it have 8? What if it was to hit 1, 2, 3, 4, 5, 6, 7, 8? Oh. I could have an axis going through and it could hit up to 8 times. Huh. If it could hit up to 8 times, if the axis is up here, what's the lowest this guy could have as far as zeros?
2.
No.
One.
Zeros.
One.
No.
Zero.
No. Yes. 0. 1.
What if it's just not touching?
If the axis is here, it could have up to 8. But what if the axis is here?
0.
It's not going to have any. What if the axis is here? It could have up to 4. Wait, what if the axis is here? Just 1, right? So it could have 1, or it could have 2, or it could have 3, or it could have, well, I should have made those all different heights. But anyway, it could have 0, 1, 2, 3, 4, 5, 6, 7, or 8, depending on how those little squiggles happen or occur. So at most, n can be, or an nth degree polynomial can have n real zeros at least, well, hold on. At least, or at a minimum. Why am I going to say even degrees can have none? What are you saying, Sophia? It's good. Odds have to have at least
1.
1. Because even if an odd has one of these guys and the axis is down here, doesn't an odd somewhere have to go opposite? So no matter what's going on up here, an odd would not be able to end going up. An odd would have to end going down. So going down is going to hit the axis. Or vice versa, going up is going to hit the axis. Yeah.
I'm confused as to how you know when it goes to like hits the axis multiple times, or it just becomes thinner.
So far we're just talking about what could be possible. So far, have we graphed this guy at all?
No.
We don't have any specific details about him besides the fact that he's an 8th degree polynomial. No matter what he looks like, he's going up to the left and to the right. And he might have up to 8 zeros. We have nothing in particular as far as what those zeros are, or we haven't talked about how to find them yet. So hang in there, Priyanka. But that's exactly where it gets hard. And that's exactly what section 2.3 is. Wait a minute, hold on, pause. So if we have up to n real zeros, does it make sense how we're going to have n minus 1 turning points? A quadratic, or any even degree polynomial that only has a down and an up and decreasing and an increasing, Sophia, Alex, can have up to 2 zeros, right? A quadratic, if it crosses, if the x-axis crosses through 2 zeros, but how many turning points does a quadratic have?
1.
Only 1 vertex. 2 branches, 1 vertex. 2 possible zeros, 1 vertex. Now check it. What if it's the weird W thing that you guys should have seen at least a couple times last year? What if it's a 4th degree polynomial that's one of those weird W's? How many zeros could it have? 4. Right? But how many turning points?
3.
So wait a minute, are we seeing a pattern? Even though for a certain degree polynomial, the 8th degree polynomial can have up to 8 zeros if it looks like this, but it could look like that or that or that depending on how the terms play out. But even though I could have 8 different intercepts, couldn't I have 1, 2, 3, 4, 5, 6, 7 different turning points? So the zeros are how many branches of that graph are possible at most. The turning points, well, you can only have at most 1 fewer than that. But each of those turning points, remember, polynomials have smooth turns, not sharp, so therefore they're all going to be maximums or minimums of the smooth turns, and those maximums or minimums happen when the graph changes from increasing to decreasing or decreasing to increasing. Guys, I'm preparing you for stuff in calculus, so we're just kind of talking about graphs and movement and what we name different things, etc. But Priyanka asked an excellent question. She was like, so how do we actually figure out where they are? Oh, struggle. How do we? Oh no, it wasn't where they were.
No.
Okay.
I asked when, because you also like if with 8 degrees of movement that it also could just have one turning point and become really thin. How do you know when it is what? Because if it could be like 4 different things, how do you know which one it is?
Okay, so similar question to what I was saying. I was just taking it further down the line. She's saying which case is this one going to be and how do we know? Well, the hard thing is there are only two ways. One way is with calculus. So, the second way is if we can find the zeros. And technically, even that, if it could have no zeros, if there are no zeros, we might have to take it a third way and say, well, by testing a lot of points. So what we're learning in section 2.2 is at best, a very informed hypothesis of what a graph looks like. It's not perfect without calculus. With calculus, Kyle was in here and he just started doing calculus. And we haven't gotten to all the maxes and mids yet. But I don't know, for some reason I brought it up as far as he said, oh, like all the different turning points, blah, 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 blah. And I was like, hey, with what you know from calculus, what's going on at each of those maximums and minimums? They're talking about slopes of graphs and tangent lines and derivatives and all this crazy stuff. And then we got to talk about with the calculus, oh, there's something happening at every max and min. So we could use the calculus to basically be like, oh, this is happening, let's go solve for that, and then come back and we'll know where they are. The problem is you guys don't know the calculus. So you have no definitive way of anything besides a parabola or a parabolic curve to know exactly where the maximums and minimums happen unless you have the maximum number of zeros possible. Then you can use symmetry in order to figure out where all those maximums and minimums are. So, at best, we're just kind of learning all the foundational stuff to do the best possible hypothesis or guess. Now, hold on. This graph over here, we're going to actually do a really good job of knowing exactly what's going on based on all the different behaviors that we see because of how many zeros it has. So I'm not saying that, Priyanka, we can never figure it out with our pre-cal skills. I'm just saying we can't always figure it out. And this would be one, because of how nasty and complicated I made it, that without going to a calculator, which at that point it's like, why don't I just graph? You wouldn't necessarily be able to figure out exactly which one it looks like. But there are a couple of tests that are kind of cool at the very end of the section that might help. When the directions say find all the real zeros of a 4th degree polynomial, aren't we always looking for GCFs anyway, guys? To make our lives easier? Let's look for the GCFs and then let's factor or use the quadratic formula. The only dilemma is we can only use this guy with quadratics. Don't worry, it's coming just slow. We can only use this guy with quadratics. Maybe it's not coming. I'll have to rewrite it. Which means if we have anything beyond a quadratic, and if we can't pull out a GCF, we might have to use some other skills, and those other skills are going to be section 2.3. So we're kind of just laying the foundation for stuff. We're not going to be given super nasty ones in this homework that we don't know how to factor. This guy's actually a really nice 4th degree polynomial if you haven't figured it out yet. So this one is going to get interesting with higher degrees, cubics and quartics and all that jazz. This is going to get interesting, but it's going to get interesting in section 2.3. So hang in there. These ones are going to be nice ones. These are going to be pretty ones. And why is this nice or pretty? What can you do? You can take out a -2 or a +2, x squared. And what's left? Which technically, if I wanted to be super snazzy, I could write this with all of his factors. Now, I wrote it super weird, but why did I write it like that?
So you can basically see zeros.
Yeah. How many zeros, how many intercepts could this have? 4. But how many does it actually have? How many different unique points will there be on the graph where it's the x-axis?
2.
3.
Because don't I have 0 and plus or minus 1?
Yeah, there's more than 1 0. Yeah.
But those are shared, right?
Yeah.
Whenever there's a 0 that's shared, because it's technically x minus 0, we call them repeated zeros. I'm introducing a vocab. Repeated zeros, we can say, have a multiplicity of, well, this one, he has a multiplicity of 2. Because 2 of the zeros, 2 of the factors are shared, are identical, have the same 0. But we could have had up to 4 different ones. We could have had up to 4 different ones. Or we could have one factor that's with a multiplicity of 4, so having none. Or we could have like an impossible 0, like a square root of a negative number situation. But this one we have 3 zeros. The maximum number of turning points, well, this is a 4th degree. He could have had up to 4 zeros, but he didn't. He only has 3. He could have had up to 3 turning points, right? That's the maximum that he could have had. But can you guys tell me how many he actually has?
We don't know.
Or do we? 3. If we were to start graphing what we did, we know at -1 and at 0 and at 1, this guy has a 0. Can you tell me about the end behavior of this guy?
He's a figure.
He's an even.
That goes down.
With a negative leading coefficient, right? So therefore, don't we know that he's going to be going down one way and down the other? True? Now there's actual snazzy notation that you guys should use in homework for going to the right, to the left, decreasing on both sides. With little arrows and infinities, actually negative infinities. But don't we basically know he's going down? Yeah. Now if we know somehow he's going down, and somehow he's going down, and we know that it has to come up through, right? It's going to have to come up through. It's going to have to come back down. Why can't it be like, oh, he has to go down. Okay. Why can't it be like, oh, it has to hit there. Why? Oh. Huh. Now, I don't know exactly how Hyatt goes about like making a table. Doesn't this seem to be the only way that it could possibly connect? Maybe going higher, maybe going lower, but I can't have more terms because it's a 4th degree polynomial. This is, I have to have 1, 2, 3, 4 different branches. I have to come up through and down. I can't go down and come back up, or that would be an odd degree. I have to end on down. There are times, Priyanka, when we can know exactly what case it is just based on the information we do. Because there can't be more than that because of the degree, and there can't be less than that, or else I won't hit all of my characteristics. Yeah.
Did you go like up and through and then hitting that point and then go back down?
Oh, yeah, actually. Laurel, good eye. She's saying, what if we went up and then down and then didn't go through? But here's the dilemma. Now I have 1, 2, 3, 4. Ooh. Depending on the situation, yeah, it's possible. Which is why, let's cover another page of notes. Because Laurel just got us to where it is even. They're both going down. And she noticed if we went through and then bounced. So here's the key. Somehow I have to bounce at one of my zeros to make it work, right? Either I'm bouncing here or I'm bouncing there, or maybe I'm even bouncing. Do you guys realize it? You could have bounced there. So I wish there was a way that we could figure out the bouncing thing, and there is. It's nice because remember that whole multiplicity thing that we just talked about down here? There's actually a page of notes for that. Here's how I know it had to bounce. I had a way, I just didn't share it yet, but we can do it right here. Whenever we have a factor like our x minus 0, where there were 2 of them, so it was like a square. Whenever I have a repeated factor, if it's repeated to an odd power, including 1, actually if it's not repeated at all, if the factor has an odd power, the function is going to be crossing through the axis at that odd power. You can think about if it's an odd power, the negatives stay negative and the positives stay positive. Like there is the possibility of a sign change. So sometimes on one side that it will be above, on the other side it will be below. That's technically why it's true. But I could say that's going to cross through. However, this one, when k is even, it's going to bounce off. That's how I knew at the 0 it was going to bounce, because in my function the 0 had a squared power, whereas these guys only had a first power. Alec, I heard you. What's up?
Oh, so it's so when you factor it, don't they always need to have the things, no powers?
Well, if there are no powers, it's an understood 1, and the understood ones will always cross.
So if they're different, if they're the same, you combine them. Oh, okay.
Yeah. So the x minus 0, you make it into the square and say, oh, it's repeated. So this guy technically has a multiplicity of 2, whereas both of these technically individually have a multiplicity of 1. I mean, it's awkward, but yeah. But in the sense of the graph, it is nice that we now know, oh, it couldn't have, like Laurel brought up, even though another one could have, depending on the factors, this one couldn't because it had to cross through on each of those and had to bounce at that one. So that kind of helps sometimes. And once again, we're learning clues to be able to do like educated guesses, hypotheses, those sorts of things. However, we're still kind of doing a best guess situation or scenario. Okay, with our best guess situation or scenario, technically, there are other tricks and clues and whatnot that are really helpful for more advanced functions. But did you guys hear me say a second ago that the more advanced functions really come in section 2.3? Yeah. We're going to have these nice ones where we have like differences of squares when we factor, we have quadratics when we factor to find the zeros. So we're not going to stress too much. But there is one other idea, even though we could have done an example where we said, hey, what do the ends look like? Find the zeros. Maybe you should plot a little baby table to know how high it goes. So plotting sufficient solution points is like, okay, you have the zeros. Maybe you should plot something in there to know how high it goes, and then you draw a curve. There's only one other big idea that we missed, and it's this. So intermediate value here. Still do your homework. Still due for tomorrow. But I'm giving grace on anyone who submits it tomorrow on the intermediate value theorem problems at the very end of homework, because we haven't talked about it yet. Sound good? Alright, get out of here. Bye, guys. Grace on anyone who submits it tomorrow. You can add a picture at any point up until Monday when the coffee drive is over and get your bonus off. Good catch, Laurel. I didn't even think about that. Because I just thought the bouncing and I didn't.